So today we have a guest with us, Ryan. You want to say hello, Ryan?
Hi.
Yeah, hi, Ryan. So I've drawn three functions on the board here, and as you can see, these functions are all continuous functions. Now by that I mean that I can draw them all without lifting up my marker. There's no breaks in them or gaps in them. They're all just continuous. They exist, I just put little arrows on them, but they really exist for all reals. The domain of this is all reals, and it's continuous. Again, I can draw it without lifting up my marker. Does that make sense to you, Ryan?
Yep.
Great. So if a function has discontinuities that are asymptotes, that is sometimes called infinite discontinuities. So this function has an infinite discontinuity right here and an infinite discontinuity right here. They're asymptotes. This function, its discontinuities are called jump discontinuities. And Ryan, I think you can guess why these are called jump discontinuities, can't you? Because the function kind of jumps at these points. There's little gaps there. Oh, we haven't, yeah, this one's going to be a little bit funny. This one with a little hole in it is called a removable discontinuity. And we'll get into more about what causes that later on. But for right now, if you can remember, one with a little hole in it is called a removable discontinuity. What was this one called again?
Jump.
Jump, very good, jump discontinuity. And what was this one again?
Infinite.
Infinite discontinuity. That's
Or you can call it asymptotic,
Could
which
be
is a
asymptotic
very
as well.
fun word to say.
Okay, so just to wrap this up, you can have a function that is continuous. As you notice, I could draw that without lifting my pen. So that is continuous function. You can have a function that is discontinuous at a point. We sometimes say there's a discontinuity because of an asymptote. So we can call that an infinite discontinuity at that x value. Or asymptotic, which is a really fun word to say. Try it.
Asymptotic.
Asymptotic.
Yeah.
It's hard not to say
Yeah,
it.
that's good.
Then we have the jump discontinuity. I sometimes think of a little bug who's walking along and goes boing and has to jump on over to continue walking on the function. So this little guy has a jump discontinuity at that x value. And then the last one, which is a little weird for now, but as Mr. Haas was saying, it's like a normal function, except there's a hole in that function, dear Liza. We call that, I should probably draw that a little more. We call that a removable discontinuity, and you'll see why a little later. Removable discontinuity at that point.
And what happens, like if we graphed that, if we gave you that function to graph on your calculator, would you actually see that little hole or?
Well, interesting that you say that. When you actually look at the graphing calculator isn't sophisticated enough to show that hole, but it shows it in the table. At that x value, let's pretend it's an x value of 1. Guess what it says? It says error, which means it doesn't exist right there. So, we're going to be talking about this next class. You're going to have a daily checkaroo on this stuff, so if you haven't written this down, write all of this down. Continuous functions and functions that are not continuous because of a point or points of discontinuity. Fun stuff.